Hello everyone, welcome to the fourth part of Azure Data Factory tutorial. Today's episode is about data flow. As we talked earlier, a pipeline is a container that orchestrates multiple activities or tasks. In previous episodes, we saw that activities within a pipeline can include copy activity to move data between sources and sinks, a stored procedure activity to run SQL operations, web activity to call REST APIs. Today, we focus on data flow, which is a data transformation component inside ADF, and it allows us to perform complex operations such as aggregations, joins, derived column, filtering, pivoting, and more. And a pipeline can contain a data flow activity, basically. So stay with me. We're going to just go through alter row, derived column, aggregate, join transformation, and filter in data flow in today's episode. And we learn how to use this stuff in Azure Data Factory. Okay, in many projects, you've got this requirement that you are seeing that at the moment on the screen. When you want to move data from source to destination, your data in the source systems got some data quality issues, and you need to cleanse data before moving that across. So here we want to just look into this. We have some data cleansing rules that we want to apply on the source data, which is a CSV file called moviesdb.csv, and it's stored in a storage account. We want to update ratings for each movie that belongs to 1988, and we want to set that to set the ratings value to 1. Also, we want to delete records earlier than 1910. And if there is any records with the null value in the years column, we want to just delete those records as well. I'm gonna use a Microsoft sample file, which is called moviedb.csv in this video. I'll show you this file quickly. It's got a couple of different columns, movie ID, title, and genres, and years, ratings, etc. And it's got more than 1,000 rows in that. So I just made it a little bit smaller. So when we are using data preview in Azure Data Factory, it doesn't take too long. And if you want to download that, this is the URL that you can download this sample file from. I put the URL in the video's description as well, so you can get it easy. Go to Azure portal, and I have a storage account. Go to the containers. I have source and target container. So I use the source one for our data source. So I just put the CSV file here. Click upload. It's uploaded. Go to ADF Studio and create a new pipeline. Give it a name, cleanse movie data. And from move and transform section, just drag and drop a data flow. And quickly name it. Go to settings and click new button to create a new data flow for us. We add our data source here, so click on this button and choose outsource. And in the data set, just click on new, Azure Blob Storage, CSV. I name it MovieDB source dataset, and from link service, choose the link service I created earlier. We browse our CSV file, which is in the source folder, as I showed you earlier. And we click on OK. Go to projection, and we just need to update the type of the column here to make them as expected. So for year and rating, the data type should be integer. So this data type and columns schema is coming from detect data type uh, button, and it gets populated automatically, but you can just double check and make sure that if anything's not 100% correct, you can just change them. You can go to data preview and check our data. Uh, just bear in mind, if you want to use data preview, you just need to enable this data flow debug at the top. It takes a few minutes to get enabled, but after that, you can just preview your data in each step. And we've got a few icons at the top, which is telling you what kind of data operation will happen to each row. So plus means insert. So this means that these rows will be inserted into the sink later. You also have this debug settings here, and you can just control the number of rows that are coming to your data sampling in the data preview screen. If you want to just increase the number of rows that loaded, you can just increase this number, but it might just slow down your data preview. I will leave it as is for now. We come here for the first data cleansing rule. We want to just set rating to 1 for 1988 movie. So for this kind of thing, we can just use a derived column activity from here. So in the schema modifier, you use derived column. And for different things that you add here, it's better to give them a meaningful name. But for this demo, to just speed up the video, I don't just give them name, I use the default name. But when you are creating a real scenario, you can just put the name so it's easier to debug your flow later or just check the results there. So here we select source one. So the data is coming from the source one to the derived column one. We select rating here because we want to set the value of rating column. And then in the expression, we go to the expression builder and we use if condition. We say if year equal 1988, return 1. Otherwise, we want to put the value of rating column. We don't want to touch the value, basically. So this expression does the trick for us. You can just go to this data preview section and check your expression result as well. So this is the output rating based on the condition that we've written here. And if you look at the value of year, the ratings been set correctly for those. So we save and finish. Next cleansing rule is deleting null years and deleting movies earlier than 1910. So for this purpose, we can use an alter row, which is here in the row modifier section. Select delete if because we want to delete some of the rows that we have in uh, our data set, and there is a rule for that. So we go to the expression builder again and we write our expression here. So if year is less than 1910 or year is null, this is our condition and the operation would be delete. So if we come here to the data preview and refresh that, you see here that for minus 1910, it's true. For 1915, it's false. So it's working as expected. So we have this negative value here in the year column to just do some cleansing on the data. So it's there on purpose. So we save and finish. And obviously for each step, you can go to data preview and check the result. And as you can see here, we've got delete icon against these two rows as expected because they get deleted based on our condition. And you can check your data sample here. Okay, then last step here would be adding sync to write data to SQL database. From dataset dropdown, I choose a dataset that I've created before. So choose this one. You can test your connection and make sure it works fine. Connection was successful. Go to settings. Here we've got our update method. You need to be careful about choosing that properly. So if you are moving data to an existing table with the existing rows, you need to just choose allow delete or allow upsert or allow update if you want to just update the existing rows in the table based on what you are doing in the alter row, for example. In this case, if we had a table populated with rows, we needed to just choose allow delete because we are deleting some rows there, and we needed to choose also allow update because we are updating the rating value. But in this case, because it's a new table, we just choose allow insert, and we can just say recreate table, and we go to data preview. There is an arrow, it tells you what is the arrow. So we need to select the table. So if I click here, uh, it opens up the data set that I've created earlier. Need to just create a new one probably. Schema should be DBO, and we want to have movies as a table name. And that's it. We can just close this one. We go back to here. We publish our changes. Publishing completed. Now I'm going to run the pipeline. So I'll go to the pipeline and click on trigger now. Click OK. Can go to monitor and check our pipeline run. So it's in progress at the moment. Okay, our run succeeded. So we go to SQL Server to check our data here. So I run this query. And as you can see, our data is populated to movies table. And obviously, the data cleansing rules apply to the data. So you can just check that out on your site. All right, we learn how to use alter row and also derived column in this requirement. And we move to the next requirement, and we can just learn more data flow capabilities there. In this requirement, we use the same CSV file. We want to aggregate the average rating of comedies movie for each year from 1910 to 2000. And then we want to save its output to the storage account with rateavg.csv name. So we go to Azure portal and we implement that using Dataflow. So I created a new pipeline and a new data flow, and I continue from here. So we add a source for that. For data source, we can use the same data source that we created for the previous requirements. So I use movie DB source dataset, and in the projection, we go and change the not genre, the year and the rating data type to integer. And we come here to the data preview, make sure that we can fetch data from the source. Yep, looks good. Then next step, we need to just filter the data to get data for comedy movies only. Also, we want to have the year between 1910 and 2000. So to achieve this, we can add a filter activity to this, and then in the filter on, open the expression builder and write our expression here. So we want to say should be greater than or equal 1910, and year should be less than or equal 2000. And also we want to select the comedy movie only. So we use this function in str. So it's for finding a substring inside a string. So in genres column, if we have comedy, this function will return its index. So if its index is not equal 0, it means that comedy is found in the genre column, and it's a comedy movie basically. So I save and finish. I go to data preview, refresh. If you look at the genre, the value that we have in the genre, it's a pipe delimited text, and you might have multiple genre in that column. So that was the reason that we used in str function to find comedy substring inside all this string. And as you can see, all movies that include the comedy genre is in this list. Before moving on, I want to show you something here. So if we go to debug setting, uh, you can control the number of rows that is fetched for the sample data. As you can see, the total number of data that is fetched is 1000 row, but you can change that to a higher number. Um, I normally don't do that because it slows down your debug, but if you need to, you can just increase this number. So like what we saw in the previous requirement, we couldn't see the result because of this, but we can just change this. Uh, Also, if you select the column and click on the statistics, it gives you some good statistics about the data in that column. Uh, it tells you if there is any null value there or not. Maximum length of that is 65, and it's 252 not null values for that column. Okay, let's go to the next step. The output of this filter, as we saw, is all comedy movies between 1910 and 2000. Now we can just do the aggregate. So we just select aggregate, and we need to group them on year because we want to calculate the aggregate for each year. And then in the aggregates tab, you say the name is rate average, and for the expression, go to expression builder, say give us the average of rating. So aggregate is used when you want to just calculate something like count or average or sum or something on your rows. So you can group them by something and then aggregate on a different column. So in this requirement, we needed to just calculate the average of ratings. So we just use the average function, but you can use the other aggregate functions as well. So we go to data preview and click refresh. Here you go. We've got year and then the average of comedy movie here. Maybe I can change the column name to comedy rate average and refresh that. It's now more meaningful. So next step, we can just write this data to our target. So we add a sink, and for sink, we create a new data set, Azure Blob Storage. We want to create delimited text. I name it comedy rating average dataset, and for the link service, Azure Blob Storage. And we want to save it in our target container. And for the file name, we want to name it rateavg.csv. Click OK. We go to setting and we choose pattern and we put that name rateavg.csv here as well. And we can go to data preview and look at the output. It looks good. So we validate our pipeline. It's all good. Publish all. This is our pending changes. Click on publish. Publishing completed. Go back to the pipeline and run the pipeline. And we go to monitor to check the pipeline run progress. It's in progress at the moment, so we wait for that to be completed. Just a heads up that if you want to cancel a pipeline run, you can just click on this button here and you can cancel the run. So we wait for that. Okay, the run succeeded. So I'm going to go to container, refresh, and as you can see, the file is being created. Check its content. And as expected, we've got the year in the first column and we've got the rating on the other column. Okay, to recap this one, if you want to get a subset of data, you can use filter for that. I think we met this requirement and we can move to the next one. We have two CSV files here, moviedb1.csv, which got movie ID, title, and genres for movies. And the second file that we've got is a CSV file as well, and it's got more data for that movies, including year, rating, and Rotten Tomato. We know that for each movie ID that we've got in the first file, there is a one-to-one relationship with the second file. It means that for each movie ID, you will have one row in the second file. And we want to just merge these two files together and create a new table in SQL Server, which is including all data that we've got for our movies. So this is a common use case in different projects that you've got data in different sources and there is a common key between those data and you want to just join them and add them in one table in the sink. So we want to do that using data flow. Also, we will look into the one-to-many relationships in the next requirement, but for this one, our assumption is there is a one-to-one relationship. Okay, let's do that. To speed up the video, I just created a pipeline called it Joining Movies. I also created a data set for our first CSV file, another one for our second CSV file, and the third one for writing data to all movies table in the SQL database. The data flow is empty at the moment. We're going to do this together. I start by adding the first data source, which is our first CSV file, MovieDB1 dataset, and in projection, you make sure that everything's fine, all good. Add our second data source, which is moviesDB2 dataset. Go to projection and need to update year and rating data type to integer. Perfect. Before moving on, we have a quick look at the data in each data source. So this is our second CSV file. We've got movie ID, year, rating, and Rotten Tomato. In first one, if I go to data preview, we have movie ID again, title, and genres. Okay, I'm gonna add a join activity here. And from the join settings, we say left stream is source 1, and for the right stream, we choose source 2. So this way, we are just joining two data sources that we've got together. Uh, we have different join types. Uh, as a data engineer, you might be familiar with SQL and the different type of join that we've got. But just shortly, if you want to join two data source with the one-to-one relationship, and you want to just grab the data that is common between two data sources on a common key, you use inner join. So we choose inner join here, and we need to just give our condition here. So the column that is in the first data source is movie ID, and we want to match it up with the second data source, movie ID as well. So this is our join condition. If we go to the data preview and refresh the data, you see that all data now are in one table, and the data is joined using the movie ID. As you can see, movie ID can be compared. So you've got equal movie ID. One is coming from the first data source, another one is coming from the second data source. And we've got the rest of the columns here. And lastly, we add our sync. All movies SQL table. Say allow insert, and we want to recreate the table. And data preview. Result is as expected. So we can just validate our work and publish it. Publishing completed. Now I go to our pipeline to run that. Trigger now. Click OK. In monitor, we can just check our pipeline status. It's in progress. Wait for that to be completed. The pipeline run finished successfully. We go to our SQL server to check what we have for all movies table. And as you can see, the data has been moved here, and we've got all columns together in one table called all movies. Excellent. We learned how to use join in data flow. We move to the next requirement. Our requirement here is pretty much similar to the previous one. As I mentioned earlier, the only difference here is in the relationship that we've got between first data file and the second one. is a one-to-many relationship. So if you look at the sample that I've got in this slide, for each movie ID, in the first data file, we've got movie ID and title. But in the second one, we still have the common key, which is movie ID between two files. But for one specific movie ID, you might have multiple values in the second file. So for example, one movie can have multiple genres. What we want to do, we want to join these two CSV file together, create one output and store it in a SQL table. And for the genre value, we want to just create a pipe delimited value for one movie ID row. We want to achieve this requirement using ADF and data flow. Let's go to ADF and implement that. I've uploaded the CSV files to the storage account and to our container. So we quickly have a look at the data that we've got there. So for the first file, we've got movie ID and title, as you can see. And for the second one, we've got movie ID and genre. And as you can see, you might have multiple movie ID in this second file. Also in ADF, I created two data sets, one for the first CSV file and another one for the second one, and created a pipeline and empty data flow so we can just continue from here. So we add those data source quickly to our flow. All good with this one. Add the second one, choose data set here. To cover these scenarios like what we have in our requirement, we can use the lookup transformation, which is here. And the primary stream is our first data source. The lookup stream is our second data source. So it means we want to look up something in the second data source, which is our second CSV file, based on a key that we have in the primary stream, which is our first CSV file. So we want to select our lookup condition here. So obviously we want to look up using movie ID. This is our common key between two data sources. Also, I ticked the match multiple rows checkbox here, so we are sure that all rows will be returned. And we go to data review and we can review data. Data is loaded here, and you've got one movie ID with multiple values for genre at the moment in the output of the lookup. So we need to just aggregate these genre values and put them in one row in next step. So for doing this stuff, we can use aggregate transformation. We choose aggregate here, and in group by, we want to group by movie ID. Doesn't matter if you choose source 1 or source 2 because we've got the same value for those movie IDs. So we group by movie ID, and when we want to aggregate, we say all genres for the column name, and we go to expression builder to create our expression for uh, collecting all those genres in one string. This is the expression that does the trick for us here. So just quickly, the collect one is making an array for us. The reduce is accumulating the array elements together for us. And toString is making them as a string. And drop left is dropping the unnecessary parts. And we are joining them using a pipe. Can just save and finish here. And if we go to data preview and check the output, as you can see, we've got the movie ID and all genres, and genres populated properly using pipe. We want to have title here as well. So if I go back, we can go to the group by and we can add another group by column here and add title. So we will have that in our output. Here you go. Now we've got the movie ID, title, and all genres. So we add a sync to write it to database. All looks good. Validate our work. All good. Publish our changes. Got published successfully. So I go to our pipeline and run it. And then we can check it in the monitor to see what is going on. And here it is. It's in progress. We had a successful run. We go to SQL Server and run our query. And here you go. We've got our data here. And the genre, all genres columns populated as expected. Alrighty, we wrap up our part 4 here, which was about data flow in Azure Data Factory. Thanks for watching the video, and I'll see you soon. Bye.